Hey there, welcome to today's video where we dive into a fascinating problem surrounding the loading and execution of the BIOS. Have you ever wondered how the BIOS ends up at memory address 0xFFF0 when the CPU starts executing it? Well, let's uncover this mystery together. In the solution provided, we discovered that in systems like the 8A888086, the BIOS was physically mapped to the memory address by connecting specific lines and using decoders to select the ROM chips. This setup ensured that the CPU would start executing the BIOS from the correct memory location. Additionally, during the 386 era, a technique known as shadow RAM was introduced, where the BIOS was copied to regular memory that could be read and written to, preventing any accidental alterations. The implementation involved a routine in the system BIOS that made a copy of the ROM modules to RAM during boot up. The memory controller then arranged read and write operations in a way that duplicated the ROM contents in shadow RAM. This method ensured that the BIOS could be accessed and executed from RAM, safeguarding it from any unwanted modifications. It's fascinating to see how these intricate processes work together to ensure the smooth functioning of the BIOS. In summary, we uncovered the mechanisms behind how the BIOS is stored and loaded in memory, from physical mapping in older systems to the innovative shadow RAM technique in more recent ones. Understanding these processes gives us a glimpse into the complexity of computer systems and how they ensure crucial components like the BIOS remain secure and operational. Thanks for joining in today, and if you enjoyed this video, don't forget to subscribe, like, and comment below with your thoughts. Remember, keep exploring and learning in the world of technology.